You are listening to recording 1B for our series on factoring quadratic equations, Unit 4, Chapter 4 of Mathematics 2200. We turn our attention here to factoring techniques for expressions with a quadratic form. We begin with the form that's similar to the one we did in our first recording, 1A, x squared plus bx plus c. So instead we're going to have p squared plus b times p plus c, where p represents an expression. So in this case, x minus 3 is the expression that we have to deal with. It's important that that expression be the same right here as it is here before we attempt to do this kind of factoring. So we'll call this p right here. So we'll say let p equal x minus 3, and now we rewrite, and we've got p squared minus 7 times p plus 12. Now from recording 1a, we know that when we go to factor, and notice that I'm using these, I'll call them square brackets, not really squares, but square brackets. The first terms must multiply to give us the first term of our trinomial. So p times p obviously does that. Now, the second terms of the brackets must multiply to give 12. Now, we have options there, like, for example, 1 and 12, 2 and 6, or 3 and 4. But they must not only multiply to give 12, but we must get a middle term that's negative 7p. So the pair of numbers that actually works here is negative 3 and negative 4. P times p is p squared. Negative 3 times negative 4, that's the positive 12 we need. We've got a negative 3p when we multiply these terms, and we've got a negative 4p when we multiply these terms. And negative 3p and negative 4p will give us the negative 7p we need. Next, we substitute back or replace the p with the x minus 3 expression that we had. So the p right here and here gets replaced with x minus 3. So I'll show those replacements with a set of rounded brackets. We have x minus 3 goes in here, and in the other bracket we also had a p, so that's x minus 3, like so. Now because there are no operations that prevent us from doing so, we can immediately remove those rounded brackets and then collect the like terms like I've done here. Minus 3 is minus 6, minus 3 minus 4 is minus 7, and we've got our final factors for the original expression. Our next example is a similar format, but notice there's an a value involved here now, so it's not just a 1 out here, it's a 2 in this case. So similarly to our last example, p is used to replace the x plus 2, and we now rewrite. We now have 2p squared plus 7p plus 5. I'll make two sets of brackets. Let's move them over a little bit, line things up a bit better. And I've got 2p and p here. And I need 1 and the 5 at the ends of my brackets, but I need to have them placed like this. That way, I will get the 2p squared that I need from here. Multiplying those terms, I will get a plus 5 like I need there. Now, I will get a 5p and a 2p for the total of 7p. So, I've got the correct factoring. All I need to do now is do my replacements. So notice I've got a p here and a p here, but this p is being doubled. So as I replace my p's with x plus 2, like so, in these two locations, I'll have to be careful right here to distribute this 2 to both of these terms before I remove the brackets. So let's do that distributing. We've got 2x plus 4 plus 5 times in the second bracket. I can remove those rounded brackets right away. And therefore I now have, collecting my like terms, in my first bracket I've got 4 and 5. 4 plus 5 is 9. So I get 2x plus 9. And in the second set of brackets, I've got x plus 3. We move on now to the difference of two perfect squares form p squared minus q squared, where the factors are conjugates. We learned about the conjugate factors for a difference of two perfect squares in recording 1a. In this case, we have two different expressions. We have 2x minus 2, which I'll represent with a p, and x minus 3, which I'll represent with a q. So we need those two substitutions because the expressions are different. I rewrite as p squared minus q squared. I can factor that as a difference of two perfect squares, p minus q, p plus q. We now replace p and q. Replace p and q. And put in the 2x minus 2 for the p in the first bracket and the x minus 3 for the q in that first bracket. We do this something similar or the same thing in the other bracket, except that we'll have a plus before the second bracket. All we need to do is distribute this negative into these two terms, and the first bracket will now become 2x minus 2 minus x plus 3. And in the second set of brackets, there's nothing to distribute, so I can remove those rounded brackets right away. Now, collecting my like terms, in the first set of brackets, 2x minus x is x. Negative 2 plus 3 is 1. In the second set of brackets, 2x plus x is 3x. Negative 2 minus 3 is negative 5. And that concludes our examples. You can factor polynomials in quadratic forms by making a substitution. If it's a trinomial, you should have the same expression in the first two positions that you can replace. If it's a difference of two perfect squares, you'll have expression number 1 squared subtract expression number 2 squared. Factors are conjugates.